George is the science boy.
George Boyd, the science guy.
George
Boyd, the science guy.
Science rules.
George Boyd, the science guy.
Inertia is a property of matter.
George Boyd, the science guy.
Boyd is the science boy.
Boyd. Hi everybody, welcome back. In this lesson, what we're going to do is describe how we measure the amount of moisture in the air. And there's two ways that we describe it. There's absolute humidity, which is just referring to the total amount of water that's in the air, regardless of how much it can hold. And relative humidity is the amount of water in the air compared to its capacity. Now, what happens is, as air changes temperature, cold air holds less moisture than warm air. So as the air heats up, picture it as a bigger container, and as air cools down, picture it as a smaller container. As the temperature varies, as it increases and decreases, the air's ability to hold water increases and decreases. So absolute humidity, amount of water vapor per unit volume. Temperature depends on how much water it can hold. Once again, cold air doesn't hold a lot of water. Warm air does. That's why in the summer it's very often hot and sticky, and in the winter the air is very dry because it doesn't hold a lot of water, and your skin gets dried out and you have to use chapstick and that kind of stuff. So warm air can hold more water than cold air. This is a key thing that you have to remember. Okay, just like in the other chapters, the altitude of Polaris equal to your latitude. This is one of those statements. Relative humidity is the amount of water in the air compared to how much it can hold. This is relative, okay, to its temperature. Right here, if we're 10 degrees, this parcel of air, okay, which is just a volume of air, could be right up to its capacity. It can't hold anymore. So picture a glass that's filled to the top. As the air increases in temperature, as you go from 10 degrees to 20 degrees to 30 degrees, the yellow represents the size of the container. So it's increasing from left to right. The container's getting bigger, but the amount of water in the air is staying the same. So the absolute humidity, the total water, is the same in all these parcels of air. However, as you go from 10 degrees up to 30 degrees, its ability to hold it increases. Now, if temperature is increasing in this direction, the air is going to appear to be drier because it's got plenty of excess capacity. As temperature decreases, what's going to happen is the air is going to become more full, and eventually when it reaches the point of 100% relative humidity, 100% full, the excess water is going to come out as precipitation. So when we move in this direction, more water can evaporate and enter the atmosphere. As we go in this direction, water is eventually going to leave the atmosphere when the air temperature reaches the dew point, which is the temperature at which the air is full. Okay? So, relative humidity is how much water the air can hold relative to its temperature, and absolute humidity is just the total volume. Dew point is the temperature at which the air is full, and that's where we're going to get rain, snow, sleet, hail, dew, whatever the type of precipitation is that's going to come out of the air. The ratio of the amount of moisture, water vapor, in the air to the maximum amount of moisture that the air could contain if it were saturated. Okay, so dew point Think of that temperature as the temperature at which we're full. That's the breaking point. We don't have to get exactly to it. The closer we get to it, the greater the chance of having rain. When air temperature reaches the dew point, the air is saturated. That means full. As air temperature drops and approaches the dew point, the chances of rain increase. So here's a little illustration. We have 80 degrees as the air temperature drops, like throughout the night. As the sun goes down, the air temperature could drop from 80 to 60 to 40. In the morning, you'll notice that sometimes the grass is wet. That's because what happened was we reached the dew point, water came out of the atmosphere, and it sticks to the blades of grass. When the sun comes back up, the temperature increases, and the air once again has the ability to hold that water, and the sun gives it energy, we get evaporation, and it goes back into the atmosphere. So here we have 35 degrees relative humidity, the same absolute humidity, total water in all parcels of air, but as the air temperature decreases, our container, our air, gets smaller, and eventually it comes out as rain. Okay? So that's the difference between humidity, which is absolute humidity, which is total water, and relative humidity, how full the air is.